All right, good morning or good afternoon. Hopefully you guys just got done going over the homework and that it went okay. You guys can always go to the tutoring center for extra help before or after school, as well as help each other out. Okay. All right, so today we are going to talk about double angle identity problems. So that means we're going to use our double angle identities from chapter 5. Okay. So just as a reminder, sine of 2x equals 2 sine x cosine x. Okay. And then remember that the cosine double angle has multiple versions. Okay, we're primarily just going to use two of them. So the first one is 2 cosine squared x minus 1. And the other one is 1 minus 2 sine squared x. Okay. So we're going to use our double angle identity problems to substitute and go from there. All right, so let's take a look at number 1. Okay. We can't go about these problems like we did yesterday because we have a double angle and we just have the cosine of x. Okay. So what you're going to try to do is substitute something in so that you are all in terms of cosine. Okay. In order to do that, we need to go ahead and set the equation equal to 0. Okay. These are not like terms, you cannot combine them. So you have cosine of 2x plus cosine x equals 0. Okay. And once again, we want to try to get this in terms of cosine, so that we don't have to do rotation, so that we can go ahead and substitute the double angle identity in. Well, if we go back to what I wrote up here, we have two different cosine double angles that we listed. Okay, we want it in terms of cosine, so we're going to use that first one. So now we have 2 cosine squared x minus 1 plus cosine x equals 0. Okay. That's the same thing as 2 cosine squared x plus cosine x minus 1. All right, so at first sight, this might look like it's difficult to factor, and we went over this last week as well. Plus y minus 1 equals 0. Okay, so how does that factor? Okay. It factors to 2y minus 1 times y plus 1. And the y's are standing for cosine of x. So now we have 2 cosine x minus 1 equals 0 and cosine x plus 1 equals 0. Okay. So this is bringing back what you guys did last week. 2 cosine x equals 1, cosine x equals 1/2, and cosine x equals negative 1. So you ask yourself, where does cosine of x equal 1/2 and negative 1? In between the interval of 0 to 360. So we have 60 degrees, 180 degrees, and 300 degrees. So this is the same process as last week. It's just to start off the problem, you have to make a substitution. Other than that, everything else is the same. All right, let's go ahead and take a look at number 2. Okay. So we have a double angle in there, and we also have a sine. So our goal this time is going to be in terms of sine or cosine. Okay. What you're trying to do is get rid of the double angle. Well, good thing is we have an identity. So we have sine of x minus 2 sine of x cosine x equals 0. So all I did was replace sine of 2x with its double angle identity. Okay. Now this is what we did last week. I know I keep saying that, but I'm just trying to reiterate the fact that we're doing the same process, it's just it's starting off with a different step. So factor out a sine of x, and you're left with 1 minus 2 cosine x. Set each one equal to 0. Okay. We get x to equal 0, or sine of x, sorry, equals 0, and cosine of x to equal 1/2. So where on the unit circle does sine of x equal 0? Right? And it's actually at three places, 0, 180, and 360. However, because of the open interval, we do not include 360. So we have 0 degrees, 60 degrees for when cosine equals 1/2, 180 degrees for sine of x equaling 0, and 300 degrees for cosine of x equaling 1/2. So cosine of x equals 1/2 at 60 and 300, and sine of x equals 0 at 0 and 180. Once again, we do not include 360 because it's an open interval, okay, so you do not include that point. Yeah. All right, I want you guys to go ahead and try number 3 on your own. You're going to write it in terms of cosine. So go ahead and pause the video, try it out on your own, share your answers, and then you guys can go ahead and hit play, and there will be an explanation. So hit pause now, please. All right, so once again, in terms of cosine. Okay. And we want to get everything to one side. And typically, you're going to want to move everything to the side of the double angle. So 0 equals cosine of 2x minus cosine x minus 1. Sorry, plus 1. So we can't use the problem the way it is. So we have to go ahead and substitute our double angle identity in. So we get 2 cosine squared x minus 1 minus cosine x plus 1. Okay. Nice thing about this problem is the ones cancel out. And you now have 2 cosine squared x minus cosine x. Okay. And we're going to go ahead and factor out a cosine x, and you're left with 2 cosine minus 1. Okay. Set each part equal to 0. Okay. And we get cosine x to equal 0 and cosine x to equal negative 1/2. Sorry, positive 1/2. Sorry, positive 1/2. Okay, so where on the unit circle does cosine equal 0 and 1/2? That would take place at 60 degrees, 90 degrees, 270, and 300 degrees. Now in your homework, if it has the directions to find all the solutions between 0 to 2 pi, make sure that you guys are writing your answers in terms of radians, which you would do by multiplying by pi over 180. Okay. So cosine of x equals 0 takes place at 90 and 270, and then cosine of x equaling 1/2 takes place at 60 and 300 degrees. All right, last problem. Okay. At the moment, it doesn't look like this is any type of identity. Okay. We don't have 4 sine of x, cosine of x. However, there is one that's similar to it. Okay. We have 2 sine of x, cosine of x. So is there some way that I can manipulate this equation so that I can get 2 sine of x, cosine of x without changing the equation as it is? Okay. Well, I can divide both sides by 2. This gives me 2 sine of x, cosine x, equals root 3 over 2. I haven't changed the problem, I just changed the way it looked. So this time I'm actually going to work in the reverse direction. And I'm going to take the expansion. I can't set sine equal to root 3 over 2 and cosine of root 3 over 2, so somehow I need to condense it. And I'm going to condense it by substituting in the double angle for sine. Okay. And because this is a double angle, that means we're going to have 2 rotations as yesterday. So where does sine equal root 3 over 2? That takes place at 60 degrees and 120 degrees. So our first rotation, 60 degrees and 120. And then go ahead and set up your second rotation right away without solving for it yet. Add 360 and get 420 and 480 degrees. Now go ahead and plug in the 2x for all of your equations and solve for x. Okay. So you should get 30 degrees, 60 degrees, 210, and 240. Okay, so once again, we couldn't set sine equal to root 3 over 2 and cosine root 3 over 2. That's not the zero product property of where you can set each factor equal to 0. So instead, we try to condense it to get down to one function, and we did that by taking 2 sine of x, cosine of x, and substituting in sine of 2x for the double angle. Okay. Your homework tonight is on the assignment sheet plus number 17. Okay. Once again, you guys replay these videos over the weekend. Monday, Tuesday, you guys are reviewing, and then Wednesday, you are taking the test. As of right now, I don't expect to be back until Thursday. So you guys will have to take the test before you guys see me. So please make sure that if you guys do have questions, you can try to email me. I don't know how much I'm going to be able to respond, at least in the first couple days, but I'll try to get on my computer over the weekend. Otherwise, go to the tutoring center during your free periods after school. And once, like I said, help each other out during homework time. If you guys have questions, don't be afraid or hesitant to ask one another. Okay. With that being said, I hope you all have a wonderful Thanksgiving and a nice 5-day break. Okay. Make sure that you guys are safe and take care. Bye-bye.